C does more than just math. In fact, most operating systems at their lowest level were written, especially early on, in C. And so C does more than just number manipulation. They do manipulation of characters, of words, and things like that. C's not the best at doing that. There's many programs that have been written, many computer programming languages that have been written since that do a better job, but it still does a pretty good job, good enough in the fact that we write operating systems with the programming language C. So that's the beginning of understanding how C can do character manipulation, is this program here. And we're also going to learn about a sorting algorithm. And so we're going to sort some various strings of characters. All right, kind of an alphabetization program. Okay, so first we're going to start from scratch. So let's go down, search for the command window CMD, bring up the command prompt, go into OneDrive, then desktop, then C code. Then let's do make project.bat space sort. The program we're going to do is called sort. And then it comes up, and then we go into File Manager, and we double click on sort.c, and up comes up pretty much empty file in this the template in Notepad++. We want to add a new include library. We want to include a new library here. So you go up to the very top, and then type hashtag include, and then in less than or greater than brackets string.h. So string.h, the string library, has all sorts of commands that you can do string manipulations. Strings are just strings of characters, just as the name implies. This is this library is also pretty important for stuff that we do, so much so that I'm going to add it to the template as well. So open up template.c, go to template folder, then template.c, and go in and add it to template as well, and then save that. So this is string. So I think I'm pretty much done with the main libraries that I usually use, especially for introductory classes. There's a bunch of others that you use, but these really get you a long way, especially for if you're just starting out. Okay, so all this program is going to do is it's just going to take letters of the alphabet that are out of order and put them in order. We're going to alphabetize letters, and so I'm going to create a character array. It's an array that stores characters. Car, and we've seen car before in the argv part of these video series. And so I say car space alpha, and then it's an array, so I'm going to give it 30 elements. I only had to give it 26, but I always do a little bit extra because you can be wasteful with modern PCs in terms of memory and stuff like that. What's a car? A car is the same size as an int, and it actually even has a numerical value, but a car is what you just think it is. It's just a typed out character. The exclamation point, the backslash, all these things are characters in addition to being, in addition to maybe having other values, other interpretations, yeah. So I'm going to just type out, I'm going to enter into alpha every letter, every lowercase letter of the alphabet, just by going through my keyboard and doing QWERTY, So I just type every left to right, the top row, then the middle row, then the bottom row, and you can see that there. I'm using a string function, a function in the string library called strcpy, string copy. Copy, quote, QWERTY, blah, 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 bm, to this new array, alpha. That's what that command says. In order to sort them, we need to understand more about characters. How do you sort how do you know that A is different than B? Right? It turns out that B is greater than A in the way that we store characters. What? What does it mean? There is a special convention. It's called the ASCII convention, ASCII character codes, ASCII. And here's a table of all the ASCII characters. There's There's 128 of them from 0 to 127, but there's actually more. There's an extended ASCII character set. There's a even larger extended ASCII character set. So it turns out that there are a lot of ASCII characters. In fact, you can make ASCII art. And so there's a whole, if you Google ASCII art, you can make art with ASCII characters just in a low-level C program on a terminal. All right, so when you look at this, you can see all the different, there's all sorts of, all the equal sign means something, and there's all these things. And there's a whole bunch of them that don't have anything there because they're kind of control characters, right? 7 is the beep, right? Beep, makes a beep number, the beep sound. So, yeah, you can even make sounds. Yeah, you can make sounds with ASCII characters, right? So, so I'm going to really focus on the ones that really matter. For example, 0, the character 0 has a numerical equivalent of 48. So on the left is the decimal equivalent, then I give the hexadecimal equivalent. That's what most people do. They talk in hex, computer people talk in base 2 or base 16 format lots of times. But I'm a human, I have 10 fingers, so I usually talk in base 10, and so the number 48 represents the character 0. That sounds weird to me. 0 should be 0, right? No. The number 0 is not the same thing as the character 0. That's the difference between a character and a number. A character represents, I'm going to give you the thing on the typewriter that represents the actual number 0, not the mathematical expression of 0. So that's the difference between a character and a number, right? Capital A is 65, and it goes all the way down to capital Z. Then lowercase a is 97. So lowercase is just capital letters plus 32, right? So you can change the case of a letter just by adding or subtracting 32 to it, right? So B is lowercase b is 98 and lowercase a is 97. So B is greater than A. You can do logical comparisons of characters. That's what we're going to do. So this has a nested loop in it. So I'm going to have two indices. I'm going to have I and J, and I is going to go from 0 to n minus 2, right? So n minus 1 is the last character. So Z should end up in alpha sub 25, for example. So I'm going to go 0 to 24 in the outer loop. In the inner loop, I'm going to go from I plus 1. So if I start at 0, it's going to start at 1 and go 1 to 25, right? And when I becomes 1, then J goes from 2 to 25, and so on. What it does is, in the first loop, when I is 0, and the value of the character in alpha sub 0 is Q, right? It's going to go through everything after that to find out every one of those that's less than Q and replace it with that one, right? So the first one that it comes up with is E. So E is going to replace with Q. It's going to switch with E. Then eventually it's going to find D, and it's going to replace with D, and then C, then B, then A. Right? It's going to actually hit A first, and then it's done. And so it puts A in the first one. The second one, it does the same thing. And by the end of the second loop, when I is 1, B is going to be in that second loop, and so on. This is called the bubble sort algorithm. It's not very efficient. It's just a conceptual way to think about sorting. There's there's a lot of sorting algorithms that computer scientists spend a whole chunk of their time when they're looking at algorithms, figuring out what are the best types of sorting algorithms. If alpha sub j is less than alpha sub I want to swap them. I need a temporary variable, so I make car temp, because if you have two things, you need a third hand. Like if I have a nickel in one hand and a dime in the other hand, I have to say swap them. You can't just swap them like that, right? You have to have a third hand, so you put the dime in one hand, put the nickel in the first hand. Your left hand is a dime in it, so you put the dime from your left hand to the other person's hand. Then you take the nickel in the right hand, put it in the left hand, and then you take the person's dime in their hand and put it in the right hand. So you need a third variable to do swap. That's all. And so that's what that is. And and that's the whole program. Now, notice the nested loop I indented twice to get to this if statement, and then there's an if in there, and so it goes in. There is no else to this. So if alpha sub j is greater than alpha sub I, don't do anything. Just go to the next. Just iterate one more time. So that's what this program does. Okay. All right. So let's compile it and run it. And lo and behold, you can see that before you have QWERTY, blah, 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 and after sorting, I put those printf before sorting and after sorting to help you interpret what was going on. And then when I print out alpha, I just say %s. %s stands for a string of characters. %c is an individual character, and %s is a string of characters. So lo and behold, before sorting, it's QWERTY. It's all jumbled up. After sorting, it's ABCD all the way to Z, and it works. That's it. We learned a ton. We learned about the nested loop, right? This nested loop structure. We learned about the bubble sort. But most importantly, we learned that character arrays are basically strings of characters, and that the ASCII character set, there are numerical equivalents of all the characters on your keyboard.